So we will have the hands-on experience on how to use factor analysis and cluster analysis for our project. Okay, so the first one is related to factor analysis. So where I can use factor analysis is, hope I am audible, right? Am I audible?
Yes, sir.
Okay. So for our project, where is that I can use factor analysis, and where in which kind of questionnaire I can use a cluster analysis. Okay, so the first one is related to factor analysis. When you look onto factor analysis as such, okay, so I'll be using it to for reducing the number of statements. Okay, so consider that you have a lot of statements in your questionnaire. So no, to analyze it, no, as such, consider you have around 20 statements, okay, which is measured under the same scale, considered as a Likert scale. Okay, so when you look onto that, okay, when you look onto that, it will be very difficult for you to analyze, the 20 statements, 20 statements, each and everything separately. So what we can do is, we can reduce the number of statements. How I can reduce the number of statement is, I can group those statements. Okay, so I can group those statements which have similar kind of thing. Then what happens is, it will be easy for me when I have when to do an analysis after me reducing the number of statements just by grouping, one or more related statements. Okay, so that is the main purpose of factor analysis, which comes under dimension reduction. Okay, which comes under a dimension reduction. So the criteria here is, when you do factor analysis, the criteria here is, all the statements should be measured under the same scaling. Okay, it should be under only Likert scale. Okay, so all the factors together, to if you're going to group it, it should be measured under the same scaling. That is one thing. And another one is, if you're doing a factor analysis, make sure that all the statements where you are trying to group, all the statements are related to independent variables separately and dependent variables separately. Okay, most of the time what we do in our research is, we work more onto the independent variable, we leave the dependent variable as such. Okay, so you will not have too many statements in dependent variable. Most of your projects are like that. But when you look onto independent variable, you will have a streamline of statements. So when we do the factor analysis, we should make sure that you are taking only the statements related to independent variable. Then only I can segregate. So what will happen is, so when you take the statements related to independent variable, consider there are around 15 statements in independent variable where you're trying to measure the independent variables. Okay. The next what you need to do is, you are grouping it. You are grouping the statements, and you will give one name to the all the groups. These groups are what we call it as factors. This groups is what we call it as factors. So this comes under dimension reduction. Okay, this is an introduction to what is factor analysis. Okay, right. So the next one is, what is meant by cluster analysis. So when you look onto the cluster analysis as such, here what I'm trying to do is, I'm trying to group the respondents. Okay, you should have a clarity. This is also a kind of a grouping thing, a segmenting thing. But what I'm trying to do here in cluster analysis is, I'm just trying to group the respondents. Okay, I'm just trying to group the respondents. Consider that you have collected data from around 150 people. Okay, 150 people. Okay, and you want to group those respondents based on their perception. Consider that you are working on customer satisfaction. Example, customer satisfaction. Okay, so you want to know how many are really highly satisfied, how many people are moderately satisfied, and how many people are least satisfied. Okay, so when you look on to that, then this cluster analysis we can work on. Okay, so what is the necessity of the cluster analysis is, you need to have variables which are measured under metric scale or even a category scale, but a similar scale should be there. Okay, the series of variables where it is metric scale together or a categorical scale. Okay, so all the variables should be measured under either a categorical scale, I can do a cluster analysis, or a completely metric scale, then I can use a cluster analysis. Okay, so the main point of difference here is factor analysis. I'm trying to reduce the statement, group those statements to find the impact and to get insight into those statements. Okay, cluster analysis, what I'm trying to do is I'm just trying to compare the uses, the respondents in groups. So when you group the respondents in groups, then it will be easy for me to analyze what has to be done in one particular segment, what has to be done in the other segment. So that is the very basic of cluster analysis. So I'm sharing the screen. Okay, so this is the data set which I want to perform. Okay, so you have lot of things here. Okay, there are a lot of things here to do. Here you have a series of statements. I think it would better that I will share the questionnaire first, then I will go with this so that you can understand. This is a questionnaire. Okay, this is a questionnaire where we have a series of statements, series of questions are there. So you have age, gender, income, all these things are categoricals. Okay, so we cannot do anything with that. We can just do frequency or comparing this statement with other things which have been already covered. Okay, so here when you look onto this, there are series of statements here. Okay, so 23 statements are there. Consider that I am trying to interpret all these 23 statements. It will be very hard for me. Okay, it will be very hard for me to work on. So what I will do here is like I will just first segregate the statements related to independent variable and dependent variable separately. Okay, these are all series of complete statement. Okay, so here when you look onto this title, it says an empirical analysis of brand experience on customer satisfaction or on satisfaction of consumers with reference to some product. Okay, so here the independent variable is brand experience. All the things related to brand experience are independent variable, and the dependent variable is satisfaction. Okay, so what I need to do is before me proceeding with the factor analysis, I should check what are the statements here is related to the dependent variable. Okay, when it is related to the dependent variable, then I cannot use it for factor analysis. Consider that you have equal number of statements for independent variable. You should do factor analysis separately for dependent variable, separately for independent variable separately, if many statements are there. Consider that for a dependent variable you have only 4 or 5 statements, then it is not necessary to do a factor analysis. Okay, that is not necessary to do a factor analysis, and it is not going to serve any purpose at all. So what I need to do is out of these 23 statements, I need to pick the statements which all belong to independent variable, because most of your projects, what you do is you write a lot of statements only for the independent variable. Okay, dependent variable you don't do much things into it. Okay, or you will concentrate you will always concentrate on an unsupervised learning where there is no dependent variable at all. So you'll have all the things. So consider that you are doing a project on customer satisfaction, that's it. Okay, then you will not have any kind of a dependent variable. You'll have only independent variable alone. Then there is no no you can just proceed with the factor analysis, because you have not written statements. I mean, you have not identified any dependent variables separately. Consider that you are working on the customer outlook of online advertisements. Okay, then you will be all the statements will be related only to the independent variable. Then you can just go ahead with that. Consider that you want to you want to measure the impact of online advertisement on sales preference or sales. Then sales statements related to the statements becomes a dependent variable. Clear? So the sentence or the statements related to the the sales, I'll keep it separately. I will take only the statements which is related to the independent variable alone. Okay. Okay, so out of this, in this project, we have customer satisfaction as a dependent variable, and other things are there are brand experience related questions are related to the independent variable. So what I need to do is I need to omit the statements related to customer satisfaction. Omitting that, I will do factor analysis for the statements related to brand experience alone. Okay, so this is our first understanding. Okay. So I'll share the SPSS file now. Okay, now the file is there. You can just look on to that. So I have put all this variables here. So the total statements are this. So from here to here, the statements are there. So what we have done is for our understanding itself, as I already told you, you just look on. These are all the statements, correct? So these are all that the 23 statements are there. So how we have identified is, so you see that B1, B2, B3, that is for our understanding that these are all the statements related to brand experience. Okay, so they have put the CS1, CS2, CS3, all these things are customer satisfaction related, which is a dependent variable. So in declaring itself, if I put like this, it will be easy for me to proceed further. Okay, because else you need to identify how it is, all these things. Okay, so how to proceed with the factor analysis? Very simple. You go to analyze, you go to dimension reduction, go to factor. Okay, so you will get the statements like this. Okay, so you will get like this. So what I should do now is I should put the variables, that is independent variable related statements, into the box. So I am putting it here. So first statement, it is independent variable, I'm putting it inside. Price, again it is an independent variable. The next one is related to quality. The next question is also there. Brand image, it is also there, so I'm putting it there. Packaging, this brand image. Okay, the next one is I like the packaging. Okay, I'm just putting it down. So like that, I will have to put all the independent statements. Okay, I'll have to put all the independent statement. I'm just for the demonstration purpose, I'm just choosing everything and I'm asking. But when you work for your project, make sure that you put only the statements which is related to independent variable alone. Okay. So I'm choosing all the statement which is related to independent variable. I'm just putting it there. Right. So I have put here. So the next step is like I need to go for this descriptive. Okay, I need to go for descriptive, where you should make sure that here KMO and Bartlett test of sphericity you need to check in. KMO Bartlett test of sphericity you need to check in. Okay, make sure that it is checked in. Then you give continue. The next one is extraction. Extraction. You make sure that it is principal component and principal component method. Okay, method is principal component method. If you want a correlation matrix, we can put. Okay, so I'm just teaching only the basic part of factor analysis. So here, based on the eigenvalue, so what is the first step in factor analysis? I'll make the software itself to segregate to the factors. So first I will check how many factors are there. Consider there are too many factors being generated. Then if needed, I will reduce the number of factors depending on my need. Okay, so that is the purpose. So either there are two options. One is extract through the eigenvalues. Okay. Or if the fixed number of factors. Okay, or I can even fix how many factors. Consider that you have in your mind like sir, it is 4 factors, it is fine, or 3 factors, it is fine. Then you can give here like 3 factors or 4 factors, like that's initially itself. But initially we'll just look on to how many factors that the software it generates, how much this SPSS generate. Then we will come back and do it again for our need. Okay, so I'll put it as continue here. So what I've did here is principal component, correlation matrix, and based on the eigenvalue or greater than 1. Okay, I'm just putting continue. The next one is rotation method. There are different methods of rotation. So we usually use Varimax rotation. So I'm putting it as Varimax rotation. Okay, then here rotation solution I'm putting it. I'm just putting it continue. Scores, it's not so much needed now. Okay, the next one is I'll put it as sort by size. So when there is a lot of iteration happens, no, it will sort when your final table, no, it will no, list in a order. The next one is if you don't want to see a lot of questions, then you can put suppress, or else it is not needed. But as of now, I'm not putting it to demonstrate you what is that in the output. Okay, right. So I'm just putting continue. Then you will get the outputs. Okay, so you will get the output like this. Okay, so I think the output is visible now. Okay, so first one is I need to look on to once now the factor analysis is done. So these are all the different tables that you will get when you do factor analysis. Okay, so the first one when you look on to this is KMO and Bartley test. Okay, so this determine the sample adequacy and check whether the factor analysis is okay with the particular data. Okay, so here we need to check the value KMO test value. You should check here it is 0.863. So according the threshold limit is it should be more than 0.6. Okay, so when it is more, it means that the factor which is separating, which you are grouping. Okay, grouping is more efficient. That is what it says. So consider that if this KMO Bartlett test is less than 0.6, then you should not perform factor analysis. Okay, factor analysis is not fit for this data. So make sure that the threshold value is more than 0.06. When it is more than 0.06, that is KMO value should be more than 0.6, then I can go in for a factor analysis. If it is not so, here itself you say that the factor analysis cannot be applied. Okay, the next value that you should check is whether it is significant or not, whether the this is related to the Bartlett test of severity. You should make sure that it is significant. If it is not significant, then you should say that the factor analysis is not applicable to this particular data set. Okay, so two things that I need to make sure. One is it should be more than 0.6. I mean, like the sample adequacy should be more than 0.6, and the significant value should be significant. What is meant by significant? It should be less than 0.05 p value. This is p value, which we call it as critical value, should be less than 0.05. Okay, so it is significant. Then I can say that the data is fit for factor analysis. Okay, so I'm just orienting this factor analysis only towards your MBA project. So I'll go straight away to the total variance explained. So when you look on to this, okay, so here it says that it has converted into 5 factors. You see that number 5 here, number of components is 5. Till that you have a data. Okay, till that you have a data, it says that till 59% around 60% it is covered. Okay, around 59, I mean it is around 60 percentage. I mean, like the 6 factors, no, 6 factors. Component 1 means it has some group of statements. Component 2 means it has some group of statements. Okay, what is this 59.7 around 60% talks about is this 5 groups explains about 60% of the entire statement. That is what it meant. Okay, so it is very good because it is more than half and it is around 60%. It is half. That we need to check that, at least that when you do your factor analysis, make sure that it is at least more than 50. Okay, if it is more than 50, it is good because the 50%, at least 50% of variability should be explained by all these components. Okay, so this is fine. So how many factors we have come as around 5 factors it has come. Okay, this is one thing. The next one is I need to next one is, so first table what I've seen, KMO table, first one. Second one is I'll be looking on to the total variance explained. Check that whether it is more. So okay, it is fine. It is around 60. So the variability is explained. Very good. The next one is I'll go into the rotated component matrix. Okay, I'll go to the rotated component matrix. So what is this rotated component matrix? This will tell you how many statements are there in one particular component. Component means factor. So you can look on to this component. We have 5 components there, and these are all the set of statements. These are all the set of statements. So how to determine from this table, like what is a component one? So what is factor one? What are the statements there? Okay, so you remember that I have given an option called sort by size, correct? So I'll tell you where it is, so that now you can make a note, because that will be very helpful when we do it. Okay, just a minute. I'll just tell you where it is, where we have given somewhere sort by size. You remember here. So in the option, we have something called a sort by size. Okay. When you give this sort by size, if you give sort by size, what happens here is this will be sorted based on, you see that it becomes like no decreasing value. You see that it goes with the decreasing value. Okay, right, and you feel that there are too much of values, correct? So this total too many values are there, and small values are all there. So consider that I want to suppress all this value to have a clear view. What I will do is I will put here tick suppress small coefficients. In small coefficient, that is which is less than 0.1, I don't want to see, because it is too many numbers are there. How to interpret becomes difficult. So what I will do is I'll put it as suppress small coefficient, which is 0.1. Okay, so I put continue here, and click OK. Right. So when you look on to, you see now the rotation table. So you don't find too many values now. It is very clear now. Okay. So how to find what are the statement that is there in factor one. Okay. So consider that it is factor one. Okay. You just look onto the values here. It is 0.7, 0.7. It goes on decreasing. And you see that this is a decreasing value. After that, it is again, and there are no values at all. So when you look on to this, it keeps on decreasing. Okay, it keeps on decreasing. And in this row, you see, in this row, which is highest, this is highest. In everywhere, when you look on to that, this values will be the highest in each row. Row wise, you should check. Row wise, which is highest, this is highest, this is highest, this is highest. So when you look on to this, till this 0.46, okay, this row is high. So it means that in the component factor one, these statements here, okay, compared to other brand, Cadbury chocolate is a worth, I am satisfied with the price, all these statements belong to factor one. Okay, here when you look onto the statement, these statements are not in order as such in the questionnaire. This gets organized based on the factor, because we have given a sort by size. When we give sort by size, this will not be just related just like the questionnaire. No, what you need to do is you need to check the statement. Yes, so you mark roughly in your questionnaire in the physical paper saying that this statement is factor one, this statement is factor one, again like this. So till this statement, it is factor one. Okay, so here you see that this is next. Here you don't have value. When you look on to this as such, here it is 0.8. Okay, here it is 0.8. This is the highest. Okay, in the row it is 0.8. So when you look on to this, when you keep on looking on to this 0.8, 0.7, it goes on decreasing. And when you look on to this point, okay, this becomes highest. The third column becomes highest. So from here, where from this 0.8, that is brand image of the Cadbury's, that is 0.8, from there to till this one, I mean, like, I think chocolate or an essential commodity, 0.8. So from this 0.8 to 0.4, all the statements here belongs to factor 2. Clear? The next one is 3. Third one, when you look on the third one, again, this is the highest. This is the highest. I'll go from here. So when you go from here, 0.81, 0.71, that is highest in this row. Here 0.75, that is highest in the row. Again, you go here, it is 0.38, it is the highest in the row. And when you go down, it is 0.1 and it is 0.8. Okay, so then what happens? It changes. So from 0.8 here that I frequently eat chocolate. Okay, from there to this one during the festival other commodities it is in a 0.84. Okay, this is 0.308, but here it is 0.384. This is highest. So the statements from here, that is 0.8 to 0.38, belongs to the factor 3. Okay, those statements belong to the factor 3. The next one is, you go here, the next one, it starts, the factor 4 starts from here, 0.8 to 9, from 8.8 to 9, 0.68, this one, and 0.52, all this 1, 2, 3, 4 values are there, which belongs to factor 4. Okay, when you look on to this, again only one statement is pending, only one statement is there in factor 5. Okay, only one statement is there in factor 5. So this is how we need to identify, what are the statements comes under which factor. Consider that out of no, there are 5 factors which is automatically grouped. Okay, based on its variability. Okay, the SPSS itself create this one. So here it is. So what you do here is, so consider that you want to have only 3 factors, or I don't want more factors, 5 factors. No, I want only 3 factors. That also we can do. Where what we should do is, you go to extraction, and go here with this option, extract fixed number of factors. Okay, there you put it as 3. Fixed number of factors, you put it as 3 and click continue. That's it. Very simple. Okay, right? So when you look on to this here, you check the total variance estimate, it is 48. Okay, because it is near 50, I can proceed further. The next one, you just look on to here. Okay, so now you have only 3 components. So basically, like you can also determine as a researcher, so how many factors you want, sometimes based on your review of literature also. Okay, so here you just look on to the values here. For factor 1, you have points and all these things. It is going. It starts decreasing. Okay, it starts decreasing till here it starts decreasing. So this many statements are there from the very first 0.7 to 0.48. All the statements 1, 2, 3, 4, 5, 6, 7, 8. So around 9 statements are there. So all these 9 statements belong to factor 1. And these statements, you just check here, 1, 2, 3, 4, 5, 6. 6 statements belong to yes, 6 here till here. 1, 2, 3, 4, 5, 6. So this 6 statements belong to factor 2, and factor 3 you have 4 statements, 0.79 this. So that related statements belong to that factor. Okay, so two factor diamond reduction or factor creation is possible. One is that the you can just allow the SPSS to create how many factors can be created. Consider too many factors, then you can restrict it by giving the number of factors that you want to extract. So this is the other point that you need to know in factor extraction. The next step in factor analysis is you need to find the average of all these statements and create a factor, or what we call it as a variable. How I will do is, I'll go to transform and I'll click onto this compute variable. Okay. What I will do here is, consider that how many statements are there, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 10 and 11 statements are there in factor 1. Okay, what I will do here is, consider that I'm just keeping a name called brand. Okay, brand experience. For an example, I'm just telling you. Okay, brand experience, or I'm just typing this brand experience. Then what I will do here is, first variable, I need to find what is it. Okay, Cadbury range of the chocolate is good. Then I'll have to find the statement here. Where is that statement? Okay, so here it is. I'll put I'll just open the brackets. I'll open the brackets and put this statement inside. Okay, I'll put that statements inside, plus what I need to do is, I need to add all these 11 statements, divide by 11. So I'll get this variable called as a brand experience, which is called as a factor 1. Is that clear? So like that I will add. So what is the second statement? Cadbury chocolate is worth the money. Okay, so I'll go this here, I'll add it here. So like that, I will add all the 11 statements. I will add all the 11 statements in the particular factor. Okay, then it will be then consider it is brand experience on. I'm just giving an example. Okay, you divide that and divide by 11. So I need to put all the 11 here. I'll put it as divide by 11. Why I'm putting divide by 9? I'm just finding the average. I'm just finding the average of all the statements together, just all the statements together, and I'm putting into the variable 1, or which is called as a factor 1. The same way I need to do for factor 2. Okay, how many statements are here? Like that I'll put. So here there are 1, 2, 3, 4, 5, 6 statements are there. So what I will do is I'll open the bracket, put all the 6 statements plus divide by 6. Okay, consider that I'm naming it as brand experience 2, but you should give a proper name. You should give a proper name. Okay, so like that I will get the 3 variables. Now instead of you comparing with each statement with the demographic variable, I can compare these newly created variable with the demographic variable in your questionnaire and start writing the interpretation. Okay, so you can take one factor, take one demographic factor, consider that it is a gender of 2 options, then you perform a independent sample t-test. You take the gender and take the variable 2, which is the factor 2, and start comparing it and doing it. Instead of me doing with all 25 statements, now it is only 3 factors I have. It will be easy for me to compare this factors with the demographic factor. So this is what is factor analysis. This is how you can proceed. What I do with the factor analysis, I'm just trying to group the statements. What is the purpose of grouping the statement? To reduce the level of interpretation that I do. Okay, because when I start grouping the statement, I'll name it as factor 1. So this factor 1, I will compare it with all the demographic variables. Consider that it is age or salary or profession. I can use some other tool to compare later, so that it will be easy for me to analyze in depth also. It will be easy for me to work on. That is the application of factor analysis. Okay, the next one is what we are going to discuss is cluster analysis. What is this cluster analysis is? When you look onto the cluster analysis, we are trying to group the respondents. Okay, so based on some kind of similarities. So what happens is I'm trying to form segments or groups where the elements inside the units inside that cluster will be homogeneous. The basic criteria or condition for applying a chi-square is all these variables should be measured. All the variables should be similar. Okay, or similar in the meant it is either categorical or metric. If it is metric, all all the scales are measured under the same scaling. And when you look on the category also, if you want to use for category, then all the variables should be under category. Okay, then I can proceed with the cluster analysis. Okay, so consider that like we have done a factor analysis, and now the variables are there. Okay, so I have three variables now. Where I am interested in cluster. Okay, so where I can apply the cluster. Consider that your questionnaire. Okay, you have a questionnaire where you ask a question based on the variable. One variable, 5 questions. Second variable, 5 questions. Third variable, 5 questions. What you can do is there itself you can add and create a variable. Okay, you consider that you have asked for 5 statements, but one variable. What you can do is you can find the average of all the 5 statements and find what is the value of that particular variable. Okay, so when you have variables like that, consider that now I have added and divided everything. Now I have 3 variables here. One is product attribute, buying motive, and purchase intention. Okay, all these things are related to brand experience. Okay, so how to proceed with cluster analysis? You go to analyze, go to classify, analyze, classify, and K means cluster, Okay, so in K means cluster, you can put all the variables here. You can put all the variables there. Only 3 variables are there. So make sure that all these 3 variables are related to independent variable alone or dependent variable alone. Okay, so make sure that you put it like that. Don't get confused with this variable and that variable. No, it will create a lot of confusions. Okay, make sure that whenever you do, even in a factor analysis, make sure that you put all the statements related to only independent variable. Here also in cluster also you put only the independent variable separately. Don't mix the independent and dependent variable together and try to form clusters. Then it is technically wrong. Okay, so what I'll do is I'll just create this cluster. You can put a number of clusters. Usually I have the habit of putting 3 clusters because like in any kind of a project I can say like higher level, lower level, and intermediate level. So that is the reason why I put the 3 clusters always. Consider if it is brand experience here, I can say that who's having very good brand experience, who's having the least, and who's okay with that kind of a brand experience. That is the reason why I'm putting it like this. Okay, so 3 is always there. The next one is iterative. You need not have to do, and savings. You can put cluster membership and distance from each cluster. Okay, right, you can put continue. I'm not going depth into what is cluster, how it is formed, all these things I'm not telling you. I'm just orienting you just towards your project, so keep that in your mind. The next one is here you can put initial cluster center is not needed. ANOVA is very much needed here, and yeah, that's it. Okay, then you can click OK. When you click OK, you see in the variable view, 2 variables are created here. 2 variables are created here in the Excel sheet. Okay, so when you look onto that, you have a variable called as a cluster number, and another variable is called as a distance from its classification cluster center. So 2 variables will be created in the variable view itself. When we say that I put the save now, the cluster number and the distance I put save now, because of that it is coming here. I'll just show you again why it has come. Classify, K means cluster. I have put save here. Here save is there. So since I put the cluster membership and distance from each cluster, okay, so it has come like that. Okay, 2 things have come now. Okay, now I will share the output. Okay, you just look on to the output. So what are the things that I need to look into the output table? Okay, what I need to look for the cluster is this 3 tables. Okay, one is ANOVA, final cluster center, and number of cases in each cluster. Okay, in each cluster. Okay, so the first one is I need to look on to ANOVA. First one is that in cluster. So I say that all the things should be significant. All the 3 variables here should be significant. Even if one is not significant, then you should say that the clusters cannot be created. You cannot perform cluster analysis. Okay, here it is all significant. What does this mean is they say that all these 3 variables in creating that 3 clusters are distinct. It means that the clusters are distinct. That is what it meant when you say that it is significant. If it is coming insignificant, let's say the result is not significant, it is more than 0.05, then what does it mean is that the clusters are formed, but there might be a little bit of overlapping between these clusters. I mean to say there might be few people who have not at all. They sometimes immediately say they are highly satisfied. Sometimes they say they are highly dissatisfied. So I cannot put those customer into one particular cluster. So that is the reason, like, we need to look into this ANOVA. Okay, so this ANOVA need to be significant. What this says is, if this ANOVA says it is significant, it means that the cluster analysis is apt for this data. You keep that like this in your mind. Okay, then you just look on to the final cluster center. So there are 3 clusters here. And you find the final the number of cases in each cluster. Number of cases in each cluster is there. So when you look on to this cluster 1, there are 70 people are there. So there are around 480 total respondents, or 480 people are there. So we have 3 clusters. So the first cluster is having 70 respondents. Okay, second cluster is having 176 people are there. In third cluster, you have 234 people are there. In here, you have 234 people are there. Okay. Okay. So this is number of people in each. So you have three clusters. Three clusters are there. In each cluster, how many people are there? That is what is this number of cases in each cluster will tell you. Okay. The next one is you have to look into the cluster. Okay, sir. Now the thing is, I need to name each cluster. How to name the cluster is based on the average. Okay, so here you find the average. So what I did is I have found the average of these cluster. I have found the average of these cluster and found that the average is least in cluster number 1 and more in cluster number 3 and moderate in cluster number 2. So based on this, I need to rename in the variable view here. So here I'm coming back here. The cluster number of the case is here. So I'm declaring here it is a bad experience. Okay, I'm just declaring as bad experience. Second one is a moderate experience. Why I'm naming here is so you can put you can use this variable for further analysis. What is the further analysis that I can do here? Okay, so I can put it like this. I'm not typing it correctly. So when you look onto the data view again here, you will get the cluster number here 1, 2, 3. All this cluster number will be there. If you view the values, then it will easily say this is sample number 1. Okay, this is sample number 1. This is sample. This will clearly says, okay, this will clearly says the QCL1 is cluster number of the case. It will tell you this respondent 1 belong to which moderate experience. This cluster, I mean the respondent number 2, he belongs to moderate. Third one, he says that he is having very good brand experience. Fourth one says it is good experience. 3 1 it says it is good experience. So this cluster has a 3 option: good, bad, and average. Then this becomes a categorical variable. Okay, this cluster becomes a categorical variable. Okay, so what I can do? This demographic variables are there. That is also categorical, and this cluster is also categorical. Okay, the output of the cluster is a categorical variable. So what I can do? Categorical plus categorical. I can do lot of chi-square. Got it? So this is how you need to proceed with the analysis. So output of a cluster is a categorical variable. 3 things are there. This is a categorical variable. Okay. And when you look on the factor analysis, the output of the factor analysis is a metric variable. Don't get confused. When you are creating variables using a factor, then that is a metric variable. Here in cluster, I form clusters. All these clusters are all these clusters are categorical variable. So when I look onto this cluster categorical variable, demographics I'll have categorical. So demographic, one demographic plus one cluster, I will put this cluster. This is one cluster, correct? So one cluster plus this. Then you can perform a chi-square to find whether there is any association between these respondents and with their experience, something like that. Okay, so to further explore more, you can do that. So this is about cluster analysis.